Before we continue on the numerical instructions, I'll just continue to use the term from the HMI, right? Remember on the HMI, we learned two components. One is the numerical input enable. The other one is called the numerical display, right? So they use the numerical and that part of the subject. I'll just use this in PLC as well, because not only we talk about the integers, we also talk about we will actually you will operate on decimal point numbers, right? So not only integer number, there are also different type of integers, right? So that's why I use the numerical term over here, all right? So I believe this is where we left off last time. So this is the last slide, talk about the move instruction, right? So over here, I just want you to bring to build a bridge, right? So I want you to have the sort of connections from what we learned before with the bit logic, right? Exam on, exam off, OTE, right? Those sort of instructions. I don't want you to forget about those instructions. And also, they have very similarities with what we are learning now with numerical instructions, right? So that's what I mean. I want you to build the bridge and have the connections between these two categories. So on this slide, you can see the briefly review, right? Those three instructions are output instructions, right? So we just use them to either set or clear the value to the single bit, which is the Boolean tag, right? So because it's Boolean tag, it's only two possible values, either 1 or 0, right? So OTE, whenever it's executed, you set the value as 1, right? But if you have the logic false, right? So OTE will automatically reset that to 0, right? That's what we learned before. And OTL set is large, OTU is unlarge. We already learned that, right? So from what we discussed on Monday, we learned that MOV instruction copy the value to a group of 32 bits, right? So that means it's the double integer tag, and it operates the target, the subject, which we just call the subject, right? Subject or object. Well, maybe we can say object. The object of the instruction is the 32 bits group. It's a group of 32 bits, right? Now, instead of a single bit, right? So they have similarity, right? So they just change the value, right? So 1 bit versus 32 bits as a group, right? And also from this example over here, right? You can see, you can even like over here, probably it doesn't make a whole lot of sense, but you can see there, you can somewhere you can program your logic like this, right? You have exam on as condition, so you can energize a Boolean, and in the same time change the value of the double integer to 1, right? Even though they're both changing the target value to 1, but they're different, right? This is a single bit, this is 32 bits group, right? And also, even to tell you that, even you can put these two instructions in series, right? Right now you see that they are in parallel, right? You don't have to always put them in parallel, right? If you put them in series, it's also okay, right? And also here I mentioned here the potential problem, right? Similar to the output energize. If you energize the same bit more than once, you have a double coil. Same thing. If you move to a target to the same double integer tag with different values, you will have a similar double coil syndrome, right? So you will see that in the lab. So up to here, is there any one of you have that question in your mind, right? So what's the practical applications with the move instruction, MOV instruction? I mean that with the OTE, OTL, OTU, we know that we can use those sort of instruction to energize a pilot light if we want, or we can start a motor starter, right? Or we can energize a solenoid valve to extend the cylinder, right? Those sort of things. That's what I mean, practical applications, right? So we can see that, right? Similarly, we have been using the exam on, exam off to check if the button being pressed or the sensor being activated, right? So that's the practical applications with the input-output devices, right? You can imagine that. You can see the physical device. But up to now, we already finished the MOV instruction, and anybody can think of the similar to that for the practical applications with MOV instruction. Has anybody think about that, or have that in your mind? Have this question? Any comments? Well, maybe you can answer my question. Can you think of any of the practical applications with MOV? When we work on the instrumentation lab 1, but what do we use that for? Remember that? Definitely that's the right direction. We use the numerical display to see what? Water level, right? Did you read water level? Analog signal, yes. Right? So water level is a analog input. Remember when you have water going to that we can call tank or column, all right? So you can see the water raise up, and then you have something read. You can see, I believe it's inches or centimeter. I forgot the unit, right? The height of the level of the water, right? So by that's analog, because you don't see any limit switch. You don't see any sensors to check individual level. We have a continuous change on the level, right? We can see the level start from maybe very low, right? Maybe start from maybe 10, 20 and go up, right? Or go down. Either way, we see continuous change, right? So that's analog input, right? So if you remember, look inside the water tank. In the center, there's some sort of a tube or something going from the up to down, right? So that's like a that you can call that probe or something. Actually, I shouldn't call that probe. It's a the tube I just mentioned is a sort of device. Then inside the tube, there's some laser or some light beam. So shoot from the top to the water, right? With the water will bounce back, reflect. So from that signal, it can sense how high is the water on there, right? Okay, so we don't have to know the details on that. So that's sort of something you can see that, right? So with the with that sort of input, right? It's not the same type of push button. It's a analog input, right? If we want to process that, inside the program, we have to copy the value to move the value around, right? So it won't be the same from what you see on here. Will probably similar to this. You can see here, one of the format, the source and the destination both are tag name. So this tag 1 on here, that could be from the input channel. And then you move from the input into somewhere in the memory so you can process, right? I mean, we're going to continue to learn math instruction or any other instructions, right? You want to start to operate on that value. So first thing probably you want to do is to transfer from input into your memory. Then you can work on that. So that'll be the move, right? On top of that, anybody remember that the pump speed? You can change the pump speed, right? The pump is driven by a motor, right? So of course we use Boolean tag to turn on and turn off. We use this sort of a Boolean tag to energize and de-energize the motor. But once you energize and de-energize, we want to control the speed, right? You set up 50% speed or 75% speed of the maximum. Remember that, right? So you can pump the water in and out, pump in, the speed will be controlled, right? So with that, definitely also it's a move, right? You want to move 50% into the controller, or you want to move 75% into the controller to tell you speed up, to tell the controller speed up the motor, right? And the other example is that if you remember that we also have the blower to blow the air, right? So then there's a valve. There's a valve to control the opening. Right? Remember that I asked you to look at the controller of the valve. It has a dial. The dial will rotate with your open or close the opening on the valve. And that directly is a output on analog, right? That's gonna be also gonna be done by MOV, right? Similar to OTE. OTE, you use that to energize a light, but with the valve, the valve is sort of analog output, right? In order to change the valve opening, you have to use MOV to change the opening to the valve. All right. Okay, let's move on to that next category. All right. So briefly, if you remember, three categories we want to talk about. There are more categories, but these three are basics. All right. So if you understand these three, you should be able to handle any other one. Right. So first one we finish. Second one we're gonna talk about now is compute or math, and after that we're gonna talk about the last category, last group called compare. All right. So let's look at the math. So that's pretty straightforward, right? If you look at the math instruction over here, I just gave you the basic 4 operations, right? Addition, subtraction, multiplication, division, right? So the last one is to get the remainder, right? MOD is to get the remainder. That's part of a division operation, right? So if we look at the Studio 5000, all right, like I said, all right, so if we go into the category of compute, right? So let me open one of the, okay. So now we can start to look at here, right? If you, I know it's pretty small, or I don't have to zoom in. You know that next time when you look at Studio 5000, you can highlight this group. You can see underneath here, there are lots of other calculations you can do with the instruction, right? We only learn the basic again, all right? So ADD, SUV, and those are the names we're gonna learn on here, right? So let's look at the format. So most of the math instructions use 3 parameters, right? So you can see over here we have ADD, and this one has the remainder MOD, right? Within the box, we have 3 positional parameters, right? With the move, right? Move instruction can only have 2. One is source, the other one destination. But with math, if you think about the math operation, we need have A and B, and then the result will send to destination, right? So that's why it has 3 of them: source A, source B, and destination inside the box. So what we need to do is with the instruction, right? If you choose ATD, there will be A plus B and send the result to the destination. Right? Very simple, right? But with the other math operation, the A and B position matters, right? So with addition, it doesn't matter. A plus B is the same as B plus A, right? The A and B can be swapped in any order. But if you do the subtraction and the division, they are different, right? You understand that? So A subtract B is not the same with the B subtract A, right? So that has order of position involved, right? And if you look at on the right-hand side, all right, the type is the same we talk about with all 3 of them. And the format we talk about a little bit, right? We talk about with the move instruction, right? So you could have numbers called immediate, or you could have tag, which means a name. So for those 2 formats, you can use that, both of them with source A and source B. But with destination, you can only have one choice, right? Tag. So I can show you on that, all right? So if we start a new run, all right? All right, so let's try ADD. All right, so we can have the new tag. We'll just use value V1 to represent source B. You can also have a tag name V2, we'll just use that. And destination, you can use a V3, value 3 to represent. You can see here, that's valid, right? You can see there's no E. E represent error, right? Because I'm doing the online edit, so that's why you can see that's here I. But syntax-wise, they are good, right? So all 3 of them can be tag. And you can see all zeros below there, right? They're representing the current value of the tag, right? So this is one source of format. And you can change that to a value, right? That'd be immediate, right? You can see here, when I change this, it doesn't complain. It didn't change error, right? If you see that's a E, that's error. But if I change the destination to a value, right? Oh, not E, yeah, that's a new version. You see here, there's a red X, right? So that means error, right? So let's try that. Let's try this. Verify. You can see when we verify, see here, error. Wrong 1, ADD, operand 2, right? They start from 0, 0, 1, 2, operand 2, invalid kind of operand or argument, i.e. tag literal or expression. So that means it complains the 3, 4, 5, 6. That's not legal, right? So you have to use this. You can choose different value, different tag name. You have to use tag name in here, right? So you can even use numbers for both A and B. Doesn't matter. You can see here, there's no red X on here. Right? It doesn't complain. All right. So that's what we need to know about the formats on the operands. All right. With the math instruction, if you, for example, if you have ADD on here, right? So let's do a demo on here. Since we have software here, we can do a demo. All right. Let's move back to here. V1. Let's change this one to V2. V1. We shouldn't change that. All right. So over here, I just add one number on here. I think I did some sort of demo with the one shot, right? So, but doesn't matter. Let's do it again. All right, on here. So, for example, if you have a trigger on here, right? So we can even use PB on here. And then once I finalize, right? So this is some potential problem here, right? So because source A is the same as destination. So when this instruction being executed, source A plus source B, right? That will add 1 on V1, and then we send the value to destination as same thing, V1. And remember, PLC running the scan very, very fast. So the moment when you turn on the push button, this instruction will be executed for several hundred times, right, per second, right? So then you will see the number jump, right? So right now I'm highlighting the PB. I can Control T. You can see I use Control T, change that very, very quickly. So now it already changed the value to 46, right? Even though you can do it very, very quickly, you have the jump, right? So that's the problem on here, right? So of course, you know that one of the solution is to add the one shot, right? You need one shot, you can solve the problem. So this is solution number one. Solution number two, if you are doing some complicated calculations, all right, you can create a new tag as intermediate result. All right. For example, if we go back to here, if we want to use V1 to do some part of a calculation, for example, we add 1, then we can times 10, something like that, right? If you do that, so let me show you on here, right? So so if you want use this to times 10, right? So then the result, if you want send to V2, so for example, this is what you want to do in your mind. First add 1, then times 10, right? Then V2 is the result. This is your first design on here, right? So let's start from the beginning, all right? Clear everything back to 0. So they all 0. So if whenever the button, that could be something as a trigger, when that is true, we want to see 0 plus 1 equals 1. 1 plus 10 equals 10. So we should see V2 equals 10, right? So let's try that. Instead, no, we got a 360 on V2, right? So because of here, that's the problem, right? That's a loop, because this particular run will be executed very fast, So that's why V1 has the number jump to 36 times 10 becomes 360. All right. So of course you can add one shot on here, right? So we already talked about that. That's one of the solution. The other solution is that you can create more tags as an intermediate result. So you can break this loop. So over here we realize this is a loop, right? So instead of keep using V1, we can create a new tag called V3. We can use V3 right away. So that's intermediate result. So that hold the value of the add one. And then from here, we can carry on to the next step times 10. All right. So if we try that, let's see what happened. So if we change that, clear that back to 0. All right. So let's try if we toggle that. Right. You can see here, I even keep the button on, right? It's still true, right? But this is 10. That's right. That's exactly what we want. Right? Even button is still true, right? It doesn't have a loop. We break the loop. Right? So by using the intermediate result tag, right? Okay. So the other option you can look into is that the CPT compute, right? That's the other instruction. You can directly put your formula or expression in here, right? You can learn it by yourself, all right? So if we want to do that, we can change this MUL to CPT, all right? And the destination, we want to use V2, right? V2, right? So that's V2. And then the expression, you can see here, when you press here, it gave you a chance to type in the formula, right? So you can type in V1, no, we should have a bracket V1 plus 1. So this is what we want to do on that. And then times 10. All right, so that's the formula you can see here, right? That's the formula we were trying. You can see here, add 1 first, then time 10. That's the old design. Now I'm using one CPT, one instruction to do the whole operation with the formula, right? So that's what we want to try. All right. So there's no complaint here, no red X, right? So we can finalize. So that's the formula on here, right? So again, I need to toggle that to off, clear that to 0, and V1 is still 0, I think. Let me open that. We can always use if you remember, we can use this, right? Use the watch. Remember, that's one thing I asked you to practice in the lab. So you can see here. Yeah. So V1, the current value is 0. So there's nothing to worry about, right? So that's 0. Let's do it. So now if we can Control T, see what happened. V2 is 10. That's right. V1 is 0 plus 1 times 10, right? Equals 10. Right? So that's the solution with this sort of problem. Any questions before we move on to next group? Right. So I use the addition as example, similar thing to other instructions. All right. So okay, the third group we need to learn from this course is the comparison. Right. Remember that before we talk about the group, right? Integer instruction for this course, I want you to focus on 3 groups, right? Move, math, and compare, right? Now we're on the last group. So with compare, it's pretty straightforward, right? So we can either use EQU represent equal. So we are asking PLC to check source A and B between 2 of them if they are the same, or if they are not the same, not equal, or if A greater than B, greater or equal than B, and less than B, greater or equals B. Right, so there are also other options. All right, I can show you here. So if you highlight compare, right, that's not math anymore, right? If you highlight compare, see that CMP, LIM, MEQ, EQU, NEQ, LES, JRT, LEQ, and JEQ, right? So those are the options, but they work in a very, very similar way, right? So with the comparison instruction, what we need to realize is that I already talked about, right? Compare them, right? So you can compare immediate or tag. It doesn't matter, right? For this, it's pretty flexible, right? You can even compare 2 numbers, right? I'm going to demo that. I'm going to show you later on, all right? So if the compare operation is true, the power flow is allowed through the instruction. So i.e. the instruction is true. So whatever criteria, right? So whatever the operation you want to do, if the result is logic true, it's similar to push button, a button being pressed or something like that, right? So that could be that's here. That's most important in red ink, not a output. It's a input instruction. So you can see here, right? You could have a true result or could have a false result. All right. So that's something you need to be aware, right? So let's see demo on here on the instruction. Okay. Let's just do it on the EQU, right? That's easy to understand, right? So if, for example, if we want to compare 2 of them, A and B, right? Notice here, right? EQU as at the beginning. That's the same situation as exam on, right? Similar to exam if the button being pressed. So that's what I mean. It's a input instruction, not output. Output, that means it's here, right? It's on the right hand side, but this is on the left hand side, right? It's the condition, right? So, all right. Let me see. Okay, I have to drag this to here, right? So that's legal position, and I can create a PL1, right? So I don't want to use PL. If I use PL, there'll be double coil, right? So you can see here, before we use a button to energize a pilot light, now you can even use this equal instruction. For example, you're checking the water level, right? For example, water level right now is represented by V1 and then 50. So that's the standard you want to compare, right? So when that water level equals to 50, you want energize a light, right? So that's basically what this run will do, right? Let's finalize it. So right now, water level V1, you can see here, it's 0. The current value, the blue arrow is 0, right? That means the light is off, right? So that's just simulate that. If right now water level reached to 25, but 25 is still not equals to 50, right? So you don't see the light turn on because this instruction gave you logic false. Similar to that, button haven't been pressed yet, or not, the value is 0, right? Exam on is false. Same thing here, right? So if we change that value to 50, right, for sure, you see the light turn on, right? Similar to this, right? If you Control T, you see the light on, right? So by the way, that makes sense, right? So before that was, what was the value before V1? V1 was, anyway, 10 plus 1, 11 plus whatever. So yeah, so that's not my concern now, right? So now we're talking about here, right? So this EQU, right? Right now the value is 50, 50 equals 50. That gave you logic true, right? Similar to this, right? You have the green bar. It doesn't have green bar on here, but you see the result on here. You turn on the pilot light, right? If you have 55, you won't see that. 55 not equals to, oh, I see. I noticed there, right? You can see here, right now we change V1 to 55. 55 plus 1, 56. 56 times 10, 560, right? So that also changed on here because that's based on V1 value, all right? So that makes sense. So if you want to energize the light whenever the water level above 50, equal is not the right choice, right? So if you look at here, what instruction I should use? If I want to check water level, once above 50, I want, it's like alarm, right? Once above 50, I want to energize a light. What instruction should I use on the screen here? GRT, GEQ, yes. GEQ is better, right? Because GEQ that also include 50. Yeah, good for you, Apollo. All right, that's good. So let's change it to GEQ. All right, then if we finalize, then we should see the light turn on, right? So you can see here the light turn on. If we change it to 50, right, that's the minimum. I still got output energized, right? The PL, the alarm still on, right? If you type in 49, then the light is off, right? So that's one thing you want be aware, right? So with the move, right? We can even use, for example, here, I can even add something here, MOV, right? We can even move, just copy V1 into V3, right? If we want to do that, right? So that has everything on here, right? So I just want you to realize you can see this, all right? CPT is or could be ADD, the math instruction, and MOV. They are both output instruction, right? They can be the last instruction in the run. I can even put in here. There's no complaint here, right? You can see they are the output instruction. So that means in your program, they are eligible to occupy the last spot in the run. They are output instruction, but the comparison instruction is different. It's input. You cannot have compare instruction at last one. So for example, all right, if I add a new run here, right? So if you add EQU, right? So if we just use V1 as example again, and 50 again, right? So we use this instruction before, right? But you can see here, we cannot do that on here. You see the red X on here, right? So it's not legal, right? If we do it, the verification, you can see here, right? That gave you the error message, error, run 3, missing output instruction, right? You understand that? So that means this is not output instruction. You have to have a output instruction in the run. So that's something you missed here, right? So that's the difference I want you to know between these 3 categories. Okay, data comparison. So again, like I said, I just want you to have the connections between the what you learned before to what you have now, right? So we talk about this, right? Move is similar to the OTE, OTL, right? And then this is new, right? The compare instruction, compute, right? Sorry, compute is the math plus move. So that's the one I want you to pay attention, the last one, right? So you can see from the demo I just showed you, you can see the compare instruction, right? Those greater, equal, or greater equal, those things equivalent to the bit exam on, exam off. You agree, right? So you can see here, right? They are the same situation. The compare provide the result, give you logic true or false. Then you can use that to do the output instruction, to drive the output instruction, all right? So that's the difference between the 3 category, but you can build sort of connection, right? Especially by this, right? I want you to get used to this sort of comparison with this, because they're doing the same thing. They provide either logic true or false for the following logic programming, all right? Over here, we're using 3 compare instructions, EQU, length, and greater. So we're doing the compare with value 1, compare against 100. So this is equal to 100 and less than 100, greater than 100, right? Again, this is input instruction, provide the condition for the result. On the result, we have 2 sets of output. One set is Boolean, right? Indicator 1, 2, 3. So this is a Boolean type. That's the only thing we can do with Boolean. We have to create 3 different lights, right, to energize them separately. So that's back into the Boolean tag. But now we learn the double integer, right? So then you can see here on this column, we use same instruction move, but we move different value into the same destination. You can see here, the destination is the same, compare indicator. So that's the advantage of integers. So we use one tag with different values to represent different situation, right? So over here, we have 3 different situations, right? Equal, less, and greater. So with Boolean, we have to use 3 separate tags. But now with double integer, we can use one tag only, but with different value. And on the HMI, different value can set up as multi-state indicator for the colors, right? So you can see the advantage on this now, right? So I think I can stop here. On the Friday, I'm going to continue from here. All right. So if you have a question, you can stay.